Okay, let's look at something. Some of you get confused because when you say 2x and x to the second power, these are not the same thing. This is 2 times x, which means x plus x. This one is x to the second power, which is x times x. As you see, the operation is completely different. If I said let x equal 4, this would be x plus x, which is 4 plus 4, which is equal to 8. Whereas over here, this would be 4 times 4, which is equal to 16. So as you can see, they're two completely different things. So be very careful when you're talking about exponents. When you say x2, that sounds like it's x times 2. So you need to say either x to the second power, or you could also say x squared. And so the same thing would be true with x to the third power. We can call that either x to the third power or x with an exponent of 3, or you can say x cubed, which means the same thing as the third power. So keep that straight in your vocabulary. It's easy to get it all mixed up. So be careful. The next rule that we're going to look at is the zero property of exponents. And the zero property of exponents is really important, okay? The zero property of exponents says, if I have anything to the 0 power, it is equal to the number 1. And I'll show you why in a bit. Another thing to be careful, if I have something like negative 5 to the 0 power versus negative 5 in parentheses to the 0 power, these are not the same thing. This one, the zero exponent, only applies to the number 5 and not to the negative sign in front. So therefore, this is negative 1 because 5 to the 0 power is 1, but my negative is not included in the 0 power, so it carries over. This one, the 0 power, applies to the whole thing. So this is equal to 1. So this is a really important thing to understand. The same thing happens when you have 2x squared versus 2x to the second power. These are not the same thing. This is just simply 2 times x to the second power. This one is 2x times 2x, which would give you 4x to the second power. So as you can see, they're not the same thing. So now let's get back to this zero property of exponents and see why it is what it is. And then we will go on into the negative exponent rules from there. Okay? So the zero property of exponents, x to the 0 is equal to 1. So the zero property of exponents says if your base has a power of 0, it is equal to the number 1. Okay, so now let's look at this. If I have 3 to the third power, this is equal to 3 times 3 times 3, which is 27. 3 to the second power is 3 times 3, which is 9. 3 to the first power is simply the number 3. Now look what is happening here. As my exponent decreases, my answer over here is always divided by the base. Okay, 27 divided by 3 is 9. 9 divided by 3 is 3. So now, as my power goes down one more, it's going to be 3 to the 0. Well, 3 divided by 3 is going to be 1. Do you see that inductive reasoning principle that says if a pattern has been established and observed, we can then keep applying it if it's a valid pattern. And so we've applied inductive reasoning to this, and we have come up with that a base to the 0 power is always going to be 1 because the base to the first power is always divided by itself. And that always brings me to 1 if I have a 0 power. So now let's keep going. 3 to the negative 1. We reduced again by 1, but what is division by 3? It is also the same thing as multiplication by 1/3. So 1 times 1/3 is 1 over 3, and that would be the same thing as 3 to the first power, even though we don't usually write the first power. Now let's do one more, 3 to the negative 2, and that's equal again, because we're going to use that same principle. Division by 3 is the same as multiplication by 1/3. 1/3 times 1/3 is going to be 1 over 3 times 3, which is the same as 1 over 3 to the second power. Notice what happens when you have a negative exponent. It becomes the reciprocal of it, putting 1 over 3 to the second power with your 3 to the negative 2 becomes 1 over 3 to the 2. Notice you lose your negative by doing the reciprocal. It doesn't make the answer negative. It makes it a reciprocal answer. So that's a really important thing to see. So now let's look at the negative exponent rules. If x to the negative n, then 1 over x to the n. If 1 over x to the negative n, then x to the positive n. If x to the n over y, negative n, over y to the negative m, this is the same as then x to the n, y to the m. So notice, when you have a negative exponent, to make it a positive exponent, you flip it over the fraction bar or the division. It was in the numerator, you flipped it to the denominator. If it's in the denominator, it becomes part of the numerator. Here we have both of them, numerator went to denominator, denominator went to the numerator. And it's because of that reciprocal. So all of these are based on negative exponents, make it a reciprocal, and the exponent becomes a positive. So there you have your negative exponent rules and your 0 property of exponents. Now let's do some more examples to give a little practice on this. Okay? 2x to the negative 2. Okay? This is going to be that negative 2 applies only to the x. So my 2 stays in the numerator, and my x goes to the denominator and becomes a positive 2. Now let's look at, in parentheses, 2x to the negative 2. Now this negative 2 applies to everything that's inside the parentheses. Thus, it's 1 over 2x squared, which is the same as 1 over 2x times 2x, which equals 1 over 4x squared. You see how both of them were multiplied. The 2 times the 2, the x times the x, making the 1 over 4x squared. So the negative exponents can be used in a lot of ways. Keep in mind, if you have a negative exponent, it's going to go from either the numerator to the denominator to become positive, or the denominator to the numerator to become positive, or both, if we have both of them, like we did on the last one. Okay, now let's look at how this goes with that quotient rule that I mentioned earlier. What if I have x to the third over x to the fifth? If I do that subtraction in the numerator, you end up with x to the 3 minus 5, which gives you x to the negative 2. And since we cannot leave it in negative exponents, this then becomes 1 over x squared. And now you know why you needed negative exponents when you're dealing with division. Okay, so that's an important thing to remember. Now, what if I had x to the third over x to the negative 5? And this is why we can do this two ways. We can either do like the bottom, make all of my exponents positive by moving this to the numerator, which is going to make x to the third times x to the fifth, which is going to be x to the eighth. Or I can treat it just exactly like it is and have x to the 3 minus negative 5, which is going to give you x to the 8th power, because minus a negative becomes a plus, and you end up with x to the 8th power. But the problem with this second step, many students forget that that negative is a number, and they don't put both of the minus signs in. They leave it with minus 5 instead of minus a negative 5. And this is why, for many of you, this may be the easier pathway, because you eliminate that error possibility of minus the negative that occurs in the second method. Okay, so that takes care of the zero property. It takes care of the negative exponent rules, and also takes care of the role of parentheses in figuring out what the exponent applies to. Remember, the exponent only applies to what it touches unless it is in parentheses, then it applies to everything. So that's a good one to remember, all right? So now let's go on to the next one.